Our focus for today is going to be on absolute values, and our learning target is I can understand that absolute values represent a number's distance from zero by finding absolute values on number lines and interpreting absolute value for a real life positive or negative situation. First, I need to talk about what absolute value is because that learning target had a lot of the term absolute value, but you don't have any idea what that means. So, when we talk about absolute value, we're talking about a number's distance from zero. And whenever we talk about distance, distance is always going to be a positive number. So, absolute values are always going to be positive. So, an absolute value is going to be the distance of a number from zero. And again, distance is always a positive number, so absolute values are going to be always positive. Now, when we write absolute value, we have a notation that we use. We actually use open brackets to show absolute value. So if I have the absolute value of -5, I would show it as two really big brackets. So this notation right here, this line and this line, this whole thing right here is the notation for absolute value. So the absolute value of -5 is going to be how far the number is away from 5. Well, again, distance is always positive. So if I take a look at it, I go to my number line, I count and see how far away -5 is from 0. So if I count, it's 1, 2, 3, 4, 5. So my distance is 5. So the absolute value of -5 is going to be 5. Absolute value of 5, again, I'm going to do the same thing. So this notation right here, this is not 151. This notation right here is absolute value of 5. I count and I see how far away 5 is from 0. So it's going to be 1, 2, 3, 4, 5. It's 5 units away. So my absolute value is 5. Notice that the absolute value for -5 and the absolute value for 5 are going to be the same value because they are the same distance away from 0. Because these two values are opposite of each other, they're going to have the same absolute value of 5. Okay, so let's take a look at a couple other numbers and let's write them as absolute values. So if I have 7 1/4 and 2 2/10 and -4 3/8, I want to write and find the absolute values. I'm going to do -7 1/4. So first thing I'm going to do is I'm going to put them in the notation. So I'm going to write -7 1/4 in absolute value notation to let me know, oh, this is what my absolute value is going to be. So the absolute value of -7 1/4 is going to be 7 1/4. Because this value is 7 1/4 distance away from 0, distance is always going to be positive. Okay. If I have the absolute value of 2 2/10, again, looking for the distance away, distance is always positive, so I write it as 2 2/10. And then my last one, the absolute value of -4 3/8 with my notation, is going to be 4 3/8 because that is how far that number is away from 0. We're going to look at absolute values and how to find absolute values. Let's go ahead and use absolute value in a real world situation. So I'm on page 163. I'm taking a look at another example. It says negative numbers sometimes represent debts. The table shows 3 account balances that represent debts. Tell which account balance is the least number. Then use absolute value to find which account represents the greatest debt. Okay, so account A, my balance is going to be -35. Account B, my balance is going to be -50. And account C, my balance is going to be -12. So it says which account represents the greatest debt. On a number line, -50 is farthest away from 0, then either -35 or -12. So -50 is the least number. But again, we're looking for the value that has the greatest debt. And so we need to get these numbers positive or showing how far they are away from zero. So if I write the absolute value of negative 50, I have a number of 50. It's 50 away from zero. If I have an absolute value of negative 35, my absolute value of negative 35 is going to be 35. And if I have an absolute value of negative 12, that's going to be 12. So again, if I put this in the perspective of money, the account that's going to have the greatest amount of debt is going to be account B with the negative 50, because it's the smallest number away from zero, but because that distance is the greatest amount, it's going to have a higher debt than account A or account C. Okay, so let's go ahead and move into your guided practice. Number 1 says explain why negative 7 has a greater absolute value than the absolute value of 6. So what they're wanting to know on this one is why my absolute value of negative 7 is greater than my absolute value of 6. And the reason being, if I find my absolute values, so if I find the absolute value of negative 7, that's going to be 7, which is greater than 6. So the absolute value of 7 is greater than 6 because the distance is further. The distance of 7 is further from 0 than 6. Okay, let's take a look at problem number 2. It says, give an example of a balance that has a greater integer value than that of account balance C, above but represents a debt of less than $5. So account balance C, we had negative 12, and we have to have a value that's going to be in between negative 12 and negative 5, or has to be a account balance of less than negative 5. The absolute value of negative 12, when we looked at account C, that's going to be 12. And then I needed something that is going to have a value that's going to be less than the debt of negative $5. So I have to have a value that is going to be smaller than $12 and smaller than $5. So my value that I could have a debt of negative 4, I could have a debt of negative 3, I could have a debt of negative 2, or I could have a debt of negative 1. Either one of those options would fill the requirement of having a debt less than that of negative 12 and also less than that of negative 5. Okay, and then we're just going to find the absolute value for this one. So my absolute value of negative 9 is going to be 9 because it is 9 places away from 0. And again, absolute value is always positive. Okay, if I look for the absolute value of 5 3/4, my absolute value of 5 3/4 is going to be 5 3/4. So one way that I can think about it is when I'm looking at absolute value, if I have a negative number in between my absolute value symbols, it's going to be positive. So the sign is going to change. Where if I have a positive number in between my absolute value notations, the number is going to stay the same and I just get rid of the brackets. Okay, so if I take a look at this one, 5, negative 5 5/10. Again, it's negative, so I'm going to do the opposite number of 5 5/10. So it's now positive. Okay, now I'm going to do something a little bit different. I'm going to compare my absolute values. And you guys saw this on problem number 1 where I went ahead and I built the comparisons. So in order to do your comparison, you need to actually find the absolute value. So don't just look at the number and say, oh, one's positive and one's negative. I'll just have the negative number be smaller because now we're looking at distance. So the first step I need to do is I need to actually find the absolute value. So the absolute value of negative 19 is going to be 19 because it's 19 places away from 0. And then the absolute value of negative 11 is going to be 11. Again, distance is always positive, so my absolute value is going to be written positive. Now I do my comparison. 19 is greater than 11. So the absolute value of negative 19 is greater than the absolute value of negative 11. If I hadn't used absolute value notation, this would change. So if I change this and take a look to where I just look at my two values and I compare my two values, negative 19 and negative 11, negative 19 is actually going to be less than negative 11 because it's further away from 0. So by putting the absolute value notation on, it could potentially change your comparison of two numbers. Okay, let's take a look at another one. So I have negative 2 and 1/2, my absolute value of negative 2 and 1/2, compared to absolute value of 2 and 5/10. So we talked about in lesson 3-3 when we have different forms to do the comparison, we want to go ahead and get them in the same form. So I'm going to take the negative 2.5 and I'm going to rewrite that as a decimal. So it becomes negative 2 and 5/10, 2 and 5/10 comparison. Now I need to find the absolute values. So the absolute value for the positive 2 and 5/10 stays the same because it's a positive number. It's 2.5 away from 0. So I have 2.5 away. Again, I'm finding that absolute value before I do that comparison. And then the absolute value of negative 2.5 is going to be 2.5. Now I compare. 2.5 is equal to 2.5. So we have done some work on locating absolute value on a number line, using absolute values to make comparisons, and then using an absolute value to interpret real world situations. So you are going to go ahead and do your independent practice, your math practices, and problem solving to finish out this lesson.